Hello everybody, welcome to the third session of the matrix algebra. In this session we want to work and I want to teach you a little about how we can do matrix manipulation. You can do matrix creations and all those addition, multiplication and all the things in the MatLab. So I'm assuming that you are a beginner in MatLab, so I'm starting from the scratch, from zero, to explain everything. So right now we have a command window in the MatLab, so I have opened the command window. So I'm gonna just write the codes in here and show you how you can manipulate matrices and create matrices of your desired matrices. So first of all, the first things that we want to start is how we can create a matrix. Let's say I want to create a 2 by 2 matrix. So you can start with the column the matrix. Let's say I'm calling the matrix A is equal to. So normally what we're doing on the paper in our session, we were putting two brackets of the matrix definitions, and then we were writing the element inside the matrix. So now here what we can do, how we can write the elements. If you're gonna start, we will start with writing the first row of the matrix. Imagine that the A is a 2 by 2 matrix and we want to write it. So for the first row I can write 1 and 2, for example. So when we put a comma in here, it means it differs the numbers. So this comma put the numbers in a row. So as much as you put a comma, so all those numbers will be placed on a row. Okay, so right now 1 and 2 are placed on the first row of the matrix A. So now if I want to go to the second row, I want to change my row and go to the second row, I put a semicolon. So when I put a semicolon means right now I'm going to the second row of the matrix A, and I'm going to define it as 3 or 4, a 2 by 2 matrix. And then if you just press the enter, you are going to see the resultant matrix. So as I told you, it's a 2 by 2 having 2 row and 2 column matrices, so it's a square matrix. And 1 and 2 is on the first row, and 3 and 4 are on the second row. So now let's define a 3 by 3 matrix. I can say 1, 2, 3. So this is the first row. I have 3 elements because it's a 3 by 3 matrix. Now I go to the second row by putting a semicolon and saying that 4, 5, 6, and then this is the second row. Now I'm gonna go to the third row, so I put a semicolon and say that 7, 8, 9. Pressing the enter, we see the result from matrix. So now, as we can see, it's the 3 by 3 square matrix having 1, 2, and 3 on the first row. So now the other way that you can define this one, instead of putting a comma, you can just put in a space. Let's say if you want to write it on the first row, for example, instead of putting comma, you can put in a space. 1 space 2 space 3, and then you can put a semicolon and say 4 space 5 space 6. And again another semicolon, you can see 7 space 8 space 9. Enter. So we get the same matrix. So this is the two way that you can define a matrix of your order. So now the next one that I want to take your attention is that how we can define and how we can call an element of the number, and how we can understand the size of the matrix B. For example, in here, the size, do you remember we were saying that, for example, M by N matrix means it has M rows and N columns. So how we can understand that property of the matrix we can just simply call a predefined function in MATLAB named as size. So we say size, a parenthesis, you put the matrix B. So this means the size of the matrix B. Okay. So now in order to let me clear here because you want to know. So now we write the size. Don't forget with the CLC you can clear the command window, but don't use clear. If you use clear all, so you are going to clear all the variables and matrices and data that you have created. So I don't want to use this one because I want to work with the matrix B. So now the size of matrix B you can understand by writing size of B and enter. So it's saying that 3 by 3. So the first number is the number of rows and the second one is the number of columns of the matrix B. So now, very cool. So it's very easy, right? Great. So you can have a rectangular matrix, such as we can define a new matrix, such as 1, 2, 3, and we can say, for example, 4, 5, 6. So it's the 2 by 3 matrix. And if I write the size of matrix C, I'm going to get 2 by 3 number of rows, the second number of columns. That simple. So now, how we can call an element of the number? Do you remember we were saying that Aij? So it means that what is the element on the ith row and on the jth column? How we can call that element? It's simple. You have the matrix B, for example. You put a parenthesis, and then you write the row and the column of the element that you want to call. For example, 2, 3. It means the number and the element who is placed on the second row and the third column. Enter. It's going to be 6. Okay? And if I write, for example, and should not exceed, because B is the 3 by 3 matrix, or 3 by 2, I don't know. It should not, if I say 4, 4, so you get an error. It says that the index exceeds the matrix dimension, because the size of matrix B is 3 by 3. So it exceeds the size. So you need to be careful with the size of the matrix. Okay, so now very good. Now we have three special matrices that we can create it in the MATLAB. The first one is gonna be the zero matrix. The zero matrix is a matrix that all the elements is 0. Okay, so we simply define it as this: A is equal to, for example, zeros, right? A is equal to zeros, and then here you specify the number of rows and columns, for example. So it has a 4 by 5 matrix with all elements being 0. You see? So it's a 4 by 5 elements, all the elements is 0. This is a very good option, using zeros option if you want to define a matrix and then later you want to assign the elements to that matrix. Is a very good way to first define it with a zero matrix, and then later you start filling out the elements, okay, for the later programming. The second one that we are going to talk is the ones number. So we have zeros and we have ones. So ones is also the matrix with all the elements being 1, right? So it's going to be cool, right? This one. The next one is the identity matrix. The identity matrix, you remember, right? The identity matrix was the matrix that the diagonal of the matrix, all the elements placing on the diagonal are 1, and all the other elements are 0. So in here we can define it also as the like this: A is equal to, we call the identity matrix as I matrix. And then here you specify just one number, for example 5. Why? Because an identity matrix must be square matrix, right? An identity matrix is a square matrix. So we just specify one number in here. If you put the enter, so you see we have all the diagonals on identity matrix is a 5 by 5 diagonal matrix with all the elements on the diagonal be 1 and all the other elements is 0, right? Cool. So now do you remember that there is one thing said, so we were having that, we were saying that if you multiply the identity matrix with any matrix, so it's going to be the same. It's like the one in numbers. It doesn't change the matrix. Let's try it here, for example, in the MatLab. So let's say that A is equal to, let's define 1, let's define 1, 2, 3, 4, 5, 6, 7, 8, 9. This is the matrix. And then let's define the identity matrix B I of, so it should be 3 because the matrix A is the 3 by 3 matrix. And then let's say, so now the point is here how we can multiply and how we can sum the matrices in here. It's very, very simple. Now, for example, you can simply define a matrix C is equal to A plus B, right? And enter, right? So A plus B is the same summation and addition in the matrices. So just add each element to each other, but you need to make sure that the size of two matrices should be the same. If I add, for example, the matrix B, if I say that C is equal to matrix B, which is a 3 by 3 matrix, plus an identity matrix, but at the order of the 4, it's going to give an error to me. It says that the matrix summation must agree. So because we are adding each element, so the size of matrix B should be exactly the same size of matrix identity of the I, so it should be 3. Now the same for the subtractions. You can define like you can define it as the C equal to A minus B. So it's going to result to the subtraction of the matrix B from the matrix A, right? Cool. Very simple. Everything is simple in MatLab. Everything in MatLab is the same as you write it on the paper, right? Is that simple? Is that simple? So now the next question is that how we can do the multiplication of the matrices. That is also simple. So we have the matrix, just define a matrix A as we define it, 1, 2, 3, 4, 5, and 6. Let this be the matrix A, and let's define another matrix B. So now if I want to define A times B, now the matrix A is a 2 by 3 matrix. So you remember that what was the condition for multiplication of matrices? So we said that the number of, so I have a 2 by 3. So the number of columns of the first matrix could be the same as the number of rows of the second matrix. So A is 2 by 3, so the matrix B should be a 3 by something. Okay? So I'm going to say it should have 3 rows, but the columns can be different. So I want to say it can be 1, 2, 3, 4, 5, for example. First row, it should have 3, sorry. Let's say 3, 6, 5, 7, 3, 5. So now, currently, we have 3 rows. Right. Oh, I'm sorry. Yeah. So why it's giving an error? Because say the dimension of matrix being concatenated are not consistent. So it means that because the first row of the matrix B I defined with the 4 element, but after that I'm defining with 3 elements, so they are not consistent. So I need to be consistent. So I can add there like this one. I can add another number here like this. Okay, this is the matrix B. Now the matrix B is a 3 by 4. So now let's see. Size of matrix A. So now let's say size of matrix A is 2 by 3. Size of matrix B is 3 by 4, right? So we see 3, 3. So it's okay. I can define the A times B right now. But now the question is the multiplications, the resultant matrix. What is the dimension of the matrix? It would be 2 by 4. Let's see. Let's define the C as A star B, which means A times B, the matrix multiplications. This is the resultant. It has 2 rows and 4 columns, right? It's very simple. Okay, very simple. But if I define right now, instead of A times B, if I say that, put the C as B times A. Let's see. You see, you're saying that inner matrix dimensions must agree. So it means that the dimensions, the number of columns of matrix B is not the same as the number of rows of matrix A. So that's why we're getting an error here. Okay, so you need to be careful about that one. MATLAB is giving you error. Now the second thing. So now I'm gonna define. That's clear. Okay. So now let's define a matrix A as 3 by 3. Yeah, 2, 3, 6. This is matrix A, matrix B. Also let it matrix be a 3 by 3 also. 4, 7, 2, 8, 6, 4, 2. Sorry, 6, 8. Okay. It's also 3 by 3. So now both when you have an A-square matrix, for example, the matrix A is 3 by 3, B is also 3 by 3. You can both A times B and B times A are, you can define that. Okay, there is no problem. They are okay. You can do that because they are square matrix of the same size. Now let's see. We said that the A times B is not equal to B times A. Let's say is that true or not? Let's say A. So let's clear here. A times B is this one. B times A is this one. You see, the matrices are totally different. So we know that the A times B is not equal to B times A in matrix space. So we need to be careful about this one. Okay, cool. Now the next thing that we need to know in here is that how we can get the inverse matrix, how we can find the determinant of the matrix, and these are the important things that we were talking. So MATLAB is simplifying everything. I'm telling you that you just you write in the MATLAB what you write on the paper. Okay, there is no difference. So now, for example, we had the matrix A also. It's a square matrix. If you want to find the determinant of the matrix A, you just write that of A as we were writing on the paper. You see? This is the determinant of the matrix A. And the determinant of the matrix B is this. Right? That simple. Okay? Now, how we can get the inverse of a matrix? Do you remember how it was painful to find the inverse matrix of a matrix, and the level of this pain would increase when the order of the matrix was increasing, right? But in MATLAB it's very simple. In the blink, just before you blink your eyes, you can just get the results. So now let's say you want to find the inverse of the matrix B. You just write inv, INV, means inverse, parenthesis, B. Wow, there you have it. This is the inverse of the matrix B. Okay? Now the question is how I can make sure that this is the inverse of the matrix B. What was the way to prove this one is to multiply the matrix B by its inverse, right? So what should be the result? It should be identity matrix. Great, right? This is an identity matrix. 1, 1, 1 on the diagonal, 0 everywhere else. So this one is the inverse of the matrix B. That's cool, right? That is very cool also. Now the question is, if I multiply now, we said that the determinant and also the inverse matrix is you can define it for the square matrices. It's not definable for rectangular matrices. So if you have a rectangular matrix, say the matrix C is 1, 2, 3, 4, 5, 6, right? So there won't be any inverse for the matrix C. So the MATLAB gives you error. It says that the matrix must be square. Okay. Also, if you say that determinant, it also gives you error. Matrix must be square. Okay. So please make sure if you're going to define the inverse, if you're going to define the determinant, the matrix must be square matrix. Cool. Any questions so far? No. There's just one thing: the transposition. How we do the transposition in the matrix. Do you remember what was the transposition? The transpose matrix was the matrix that we were changing the rows by the columns. Okay? So let's say we have the matrix A. If I want find the transpose of matrix A, what were we doing on the paper? How we were defining by putting a prime, right? As a transpose. And here also we put a prime. That's simple. This is the transpose of matrix A. Isn't it cool? It's cool. It's cool. It's very fast. We can define anything. Now, one important, very interesting things is that. So, what is the transpose of the matrix identity matrix? What do you think? Let's say I of 5 and the transpose itself. Yeah. If you take transpose, if you inverse, everything is going to be the same because it's an identity matrix. It's like a 1. It's like a 1. 1 over 1 is 1. If you just inverse it, it's 1. The transpose is 1. Everything is 1. Okay? And there is one cool properties. So what is the determinant of an identity matrix? You guess, right? You guess it, right? It's 1. Yeah, it's 1. Any identity matrix has a determinant of 1. So the 1 is also a very special number here. Cool. I hope you enjoyed this session, and I will prepare some homework for you to work. It's gonna be 2 questions. One on the matrix algebra, and the second one is gonna be on the MATLAB part. I hope you enjoyed this one, and thank you for your attention, and stay safe.